Hello, everybody. My name is Nate. I'm an engineer at Prefect, where I work on the open source and a couple other things. Um, and today I'm going to be doing a bit of a speed run through just getting started with Prefect, talking a little bit about organizing things, logistics of getting set up, and yeah, let's get right into it. I'm going to assume that you have nothing except for hopefully Python installed on your computer, and um, so let's go to a new project. I have some stuff that I was doing before, but let's get rid of all that. Let's make a new directory called new prefect project, and I'll go ahead and crawl into there, and I'll use a tool to create a virtual environment that I really like called UV by Astral. A lot of people really like it nowadays, but it's basically like pip, but only faster because of Rust. You can use whatever you want, like Conda or whatever the heck, but I like UV a lot, so I'm going to do UV venv to get myself a virtual environment, and then I need to activate it. So I'll do source.venv bin activate to set my interpreter as this one that I just created, but I don't really have anything in here. UV pip list. I probably have absolutely nothing. So what I'd like to do is pip install Prefect, and notice that I'm using the UV as a prefix because that's how you use UV. You get that nice Rust speed. So watch how fast this goes. Bang, installed. That's why UV is really nice. So now I have, importantly, I'll clarify, I have the pre-release version of Prefect 3, so that's going to be UV pip list of Prefect. So that's 3.0 RC16, so the 16th release candidate of Prefect 3. We've been releasing them over time. But Prefect 3 has Pydantic 2, and it has some new exciting stuff like background workers, but we're not going to talk about that in this video. We're just going to talk about the simple things that will be entirely common between Prefect 3 and Prefect 2. So let us open our editor, where I have no files except for my virtual environment. So what I'll do is close this big old sidebar and then open a new file, and I'll just call this main.py, and I'll blow it up so it's really easy to see. And so if you're coming from a legacy tool or just running your own Python code someplace, you probably have a bunch of code like load data, which takes I don't know, it takes some reference like query, and it returns, sure, list of dictionaries, something like this. Load data from a database or API, and like we'll return some random stuff. Let Supermaven go crazy, which is just basically like Copilot. And then maybe we have another one called process data, like it gets the idea. And then we'll have save data. Yeah, this is perfect. So this is like very, very familiar boilerplate ETL. Like you could mentally replace this with like pretty much any database or S3 or whatever you're doing, and then maybe you have some CPU bound work to do on that data, and then you push it back somewhere else. This represents, at least at a high level, a lot of the work that people do in the cloud, at least in the data realm. And if it doesn't, you can probably see how you could map between this and what you have. But basically what is important about this is that we have a series of Python functions that pass data to each other. And so Airflow looks at this problem and they say, okay, let's create a DAG right away that represents the relationships between our nodes, which would be like our functions, like load data is a node. And it has an arrow that goes to process data because it passes its data. Whereas Prefect is sort of like, well, how about you just write Python code? And if we find a function that's decorated with Prefect stuff, we'll put it on the Prefect map, and we'll tell you like what came inside and how they relate to other tasks. It's more circumstantial. We discover a graph that represents your workflow as it runs based on the control flow of your Python code, which means that you just get to write normal Python code without making it like prefect code, at least to start. So let's go ahead and take this normal code, which we should probably make sure that it actually runs like normal code, first of all. So let's say Python main. Looks reasonable. Maybe we should add a little bit of logging to prove to ourselves that what we think is happening is actually happening. So we could say like loaded data, process data, save data. There we go. Yeah, that looks right. Okay, so this is just normal Python script. So now let's turn it into a prefect thing. So it's pretty simple to do that. You can say from prefect import flow, which is just a nice little decorator. And we'll go, there's actually one more step we're going to do. We're going to organize our main block here into a main function, just to make it clean. And so I'm going to say main, yes, you know what I wanted. So let's, now we have main that we can call, right? So let's decorate main with flow. And that is the bare minimum that we have to do prefects. So let's go back to our terminal and run this now. And what we should see is that mostly everything is pretty much the same. We have a little bit of latency as it starts because it's going to talk to the API. But most of the stuff that people are doing in the cloud, with Python anyways, is I/O bound. And so if you have a little bit of latency, it's not the worst thing in the world. So what we'll see here is that we have not much going on. We have some task runs. Ooh, what's this? Oh yeah, that's right. We don't have any task runs. That's correct. I was confused for a moment, but it actually makes a lot of sense. Because all we did was just call our thing. And so there's no sort of information to drill down into. We get some, when it was created, when it was updated, it's stuff like that. But nothing that's super interesting. And that's partly because we haven't instrumented the rest of our code. So let's do that now. And all we have to do is say like, hey, I want to say that loading data is sort of an atomic piece of work that represents an important portion of what I'm trying to do in my overall workflow. And so like these three functions, which may very well call other functions, are important checkpoints that I want to make sure function. And maybe this right here is some I/O call, like I go fetch data from an API, and sometimes it just randomly breaks. So I'll add some retries. But maybe it only retry, like I only want to retry it in certain cases. So I could say retry condition function, and now I can, do logic to decide whether I should retry. But let's not get too ahead of ourselves. Let's just start with the simple thing. We have our task decorators. I keep trying to open iTerm. Let's go back to our code and run it now. And what we should see is that we have a little bit more interesting information going on. So if I go back to the UI, we'll see that we now have 3 tasks that were recorded, and they have relationships between each other that are sort of implicitly defined by the structure of our code, right? Because data, load data, produces data, which is passed to process data. There's that arrow right here, and same goes for process and save. So now we have something that's a little bit more interesting. We have task runs that are independently retriable, cacheable, etc. So this is sort of how you can incrementally adopt Prefect into just native Python code that you already have. And so the last thing I want to cover in this video is how to elevate this thing really easily into a deployment that I don't need to be on my machine to trigger. So what I mean by that is right now, in order to run this thing, I need to literally go into my terminal on my computer and say Python main and run it here, unless someone hacks me and does it remotely or something like that. But what I'd like to do is be able to trigger this from anywhere, or maybe even put it on a schedule. And so the simplest way to do that is just to take what we have now and say serve on the end of here. And what I'll do, just for the sake of demonstration, is I will get ourselves a from Prefect client schemas, or I think it's just schedules. No, client schemas schedules, import interval schedule. Excellent. And what we'll do is slap schedules. We'll give ourselves one schedule, and it's going to be an interval schedule. Sweet. Yeah, sure. I don't care about the start date, actually. But let's say interval. Actually, I think this is a time delta. Yeah, it's a time delta. So let's import that. Thank you, VS Code. Great. So now let's actually give it a name. My first deployment. Cool. And that's all we need. So let's use the correct terminal and now run the same script the way we did before. And now this time it's not going to run right away. It's going to start a process that's listening for scheduled runs of this new deployment that we just created. And so we see that one is scheduled for about an hour from now. And let's actually shortcut this and do it now because I want to see it happen. So my first deployment, every minute. Oh, I did say every minute, that's right. Let's do a quick run. So let's see what happens. We just scheduled a run. It should get picked up in just a second. There we are. And so everything ran, yeah, just the same way as you would if you ran it interactively. It runs the code, etc. We have the stuff that happens. And so now this will happen every minute until I kill this process. And so there's a lot of stuff, there's a lot of directions you can go from here. Most of them have to do with infrastructure and configuration. But this is the simplest way to go from Python that you already have to a deployment that you can go straight into the UI and anyone who has access to this UI can now trigger or configure this deployment so that the code can run however you need it to run. And I will show also that one other thing. Yeah, let's show one other thing, which is that let's say we want the query to be parameterized so that the query can be passed in by a user who has no idea what the code looks like. So let's stop clicking random buttons, actually, and let's go back and restart our serve so that we get the updated deployment. Let's click on this, and let's go into custom run, where we see now that we have this select, we can put in whatever we want for here. Select star from users, blah, blah, blah. Okay, so now anyone can just provide a query, which may not be safe, but I think you get the idea. You can empower non-technical users who are not going to be looking at code to provide inputs to your workflows that you design for them so that's convenient or something like that. So yeah, this is the beginning. I just killed the process. There could be a larger discussion that maybe I'll come back with in the future about decoupling the implementation of this script from the process that's listening for runs of it. So what I mean is that you could have this sort of flow, this main flow, in a place in your GitHub repo, happily living, and you could have one process that's running on your VM that your company bought access to, and you could have 20 people with different flows all deploying so that those flows will run on the same VM in a process. So that's like decoupling the code that you wrote from the infrastructure that it's running on, because maybe you have a DevOps guy and you just sort of like let the DevOps guy handle the VM. So this is like the intro. I hope this was helpful in its own right. Come back and talk about work pools and workers later and how to decouple your code authoring from the execution environment and its configuration. But yeah, feel free to drop any questions in the comments, and I will see you next time.